So after having described the causal nature of the scenarios, identifying this vertical axis, and after having treated in particular the anticipatory scenarios, in this case starting from visual information, we tried to backcast, if you want, the causes that led to this final state. We try to describe the horizontal axis, namely this tension between descriptive and normative scenarios. The descriptive scenario states an ordered set of possible occurrences regardless of the desirability of the outcomes, whereas the normative scenarios are those which incorporate values, concerns, and interests of the developer, or if you want, of the stakeholders of the concerned society that is somehow constructing this scenario. In natural hazard management, in natural hazard risk management, in the assessment case, the focus is set on the construction of descriptive scenarios, whereas normative scenarios represent more the case when, let's say, a desired system is envisioned, when stakeholders and experts together try to figure out how to enhance the current system. Obviously, this current system has to be enhanced to meet a certain number of objectives and a certain number, and to meet certain needs of the concerned society. And it's good if we are able to define scenarios, in this case normative scenarios, that are somehow describing with accuracy and precision what we want. So we are not blindly somehow establishing a certain new state. We are following a desired path if possible. Obviously, in doing this, we have to confront ourselves throughout the planning process with the possibilities given by the system itself, with the available resources, with the ecological conditions, for example, if we think about a river or a river system, with certain boundary conditions, if we have certain hydrological regimes. Obviously, we cannot expect particular river morphologies if this is not allowed by incoming water discharges or sediment volumes. The descriptive scenario, let's say the classical example of a descriptive scenario is the hazard map. In this case, has a typical hazard map for flood processes and debris flow processes. It's shown in this case, the three colors describe inundations patterns reflecting different recurrence intervals and reflecting different levels of intensity. So normally there is a matrix where which helps us to identify the intensity of the hazard, if you want, the severity of the process, depending on its likelihood, on its recurrence interval on the one hand, and on the local intensity on the other hand. So in principle, in this case, a bundle of scenarios is summarized through a hazard map. But the result is a descriptive scenario. So we are somehow doing this exercise without incorporating normative values, let's say. Here I'm showing you a tentative example of envisioning a possible river corridor end state, desired state, that should somehow guide the planning process in a more focused way. So here there are two scenarios in this, reflecting different interventions intensity, reflecting different river widths that should be compatible with other system constraints like surrounding roads and settlements. Let's say visualizing the desired end state and incorporating in this case also normative values, answering in principle the questions in which environment you want to live in the next couple of decades, helps to funnel the planning process and to, if you want, to reflect throughout the planning process if the planning construct, if the result of the planning process is in line or not with this envisioned river corridor. Let's talk about the third axis, the inclined axis, which is the temporal dimension. In this case, we distinguish between trends and peripheral scenarios. Trends or timeline scenarios represent hazardous events which are in a causally related manner to provide explanations of how relevant factors evolve in time. So, as I already mentioned, a classical example is the temperature evolution within the next 20 years, depending on certain emissions assumptions. Conversely, on the other hand, peripheral or cross-sectional scenarios represent a description of a particular future point in time. We will now see specific examples. This is the case of the temperature increased scenarios. There are different scenarios depending on emission assumptions about the emission intensity. Obviously, the emission intensity depends on other assumptions about, if you want, the management of the natural resources available or the transformation of our society towards the use of renewable energy, for example. Obviously, these choices and these dynamics will affect the emission intensity, and as a consequence, due to the climatic machinery, if you want, this will affect the temperature increase over the next 100 years, for example. So these are the trend scenarios. Conversely, the so-called cross-sectional scenarios or peripheral scenarios are a bit depicted in this way, where we get an idea about the possible sea levels, depending obviously on the global climate change that might be plausible in certain time points in future. For example, in the year 2030 and in the year 2050. Let's talk in this lecture about and try to understand that scenarios are closely related to the production of visions. For example, a classical vision is a normative scenario, or is very similar to the concept of a normative scenario. Let's talk also about the visioning process in relation to sustainability. I chose to, let's say, to include in this first lecture also the part about visions and visionings, in order to cover also this part that is becoming more important also for the planning sector. So planning means first and foremost also the production of these future visions that somehow guide, like a light beam, the following planning process. So the term vision is used in reference to a desirable state in the future, as intended by several authors. So visions are a subgroup of scenarios, because we are somehow, the desirable states should be as a subgroup of the possible future states. Obviously, we can also desire future states that are seemingly impossible. So it depends, obviously, along the time axis if we are able to transform our system, and this, let's say, arguably impossible states may become possible, but obviously this depends on the possible transformations. So without going into such level of detail, let's say that visions are a subgroup of possible future scenarios. Visions are demarcated from predictions, so visions are not linked to particular assumptions about the probability of occurrence of fulfillment, about the likelihood of such future states. And visions are also different from the pathways that leads up to a vision. A vision is, if you want, a portrayal of a future state, and then a distinct problem is how to reach such a future state, and the efforts related to such an endeavor, if you want. So visions can be operationalized in specific qualitative and quantitative goals and targets, and visualized through specific visualization techniques. So let's go through the 10 quality criteria for sustainability visions. So in principle, if you portray a vision, this vision should be sufficiently visionary in the sense that it should portray a desirable future state with elements of surprise, also of utopian thought, but also of farsightedness within a holistic perspective. These 10 criteria have been pointed out and summarized very well by Vik and Ivaniewicz in 2014. So the vision has to be obviously under, let's say, the mainstream ecological thought sustainable, in the sense that what we are portraying should comply with sustainability principles, but can obviously feature radically transformed structures and processes. Visions should be systemic, in the sense that we have to represent the system holistically, not only sectorally. So there have to be linkages between vision elements. Vision has to be coherent in the sense of compatible goals. So these goals should be, as far as possible, free of contradictions, and should be also plausible. That means that it should be possible, at least in principle, to reach such conditions. And this should be informed by empirical examples, theoretical models, and pilot projects. Visions, moreover, should be tangible. That means that they should be composed of clearly articulated and detailed goals. Relevant, the goal should be salient, of relevance for the society, for the concerned people. Nuanced, that means that they should also this vision should also reflect priorities, because not everything is realizable at the same time, and depends also on the availability of resources. So focus on priority is very important. Visions, moreover, should be motivational and shared. Motivational means that should inspire and motivate people to attain certain goals and to envision a change, and should be shared. That means that a convergence should be met between and an agreement should be reached among the relevant stakeholders and the concerned society.